Hello Gaudi class and welcome to Maths. We're going to start with our 4.5 minute arithmetic and I'm going to give you the same warning I do every single day. I'd like you to time yourself and just take 4.5 minutes. If you want to keep going and do more extensions, then you can do that after the lesson or during, you can pause and carry on after your 4.5 minutes. But what I don't want you doing is I don't want you doing the extension instead of today's lesson. Okay, so pause the video, do your challenges, and then we'll go through the answers. Right, let's start with challenge 1 as always. 14 add 2. And again, I can do that in my head. I'm going to put the 14 in my head and the 2 on my fingers. 14, 15, 16. So there are different ways to do these questions, and I'm going to just use my head today. Tomorrow I might use the ruler. 16, take away 4. So 16 in my head, 4 on my fingers, and I'm taking away this time, so I'm counting backwards. 16, 15, 14, 13, 12. 19, add 2. So 19 in my head, 2 on my fingers, 19, 20, 21. And I'm going to do the extension as I always do on my board. So today the answer was 6. So I'm going to have, 1, 2, 3, 4, 5, 6. That's my answer. I'm putting them in a box and I'm not touching those. So 6 in the box, and I've got none outside the box. I've got 6 altogether. Okay, let's put 1 outside the box. So now I have got 7. If I take away my 1, then I've still got what I need in the box. So I take away the 1 and I've got my 6 in the box. Draw another one. I now have 8 altogether. Take away the ones that are outside the box. So I take away my 2 and I've still got what's in my box. So I've got my 6. And I can keep going. I'm not going to draw the picture anymore because I can actually see the pattern for my very wonky numbers on the board. So 6, 7, 8, 9, take away 0, 1, 2, 3 will give me 6. And then I can do 10, take away 4, and 11, take away 5, 12, take away 6. And again, it depends on how long you've got, but you could carry on doing that pretty much all day. Let's go back to our challenge 2 then. Challenge 2, 20, add 57. And I'm going to do this one the other way around because I can. Addition is commutative. So I'm going to do my 57, add 20 because I can count on in tens. So 57, 67, 77. I've counted on my 2 lots of 10, 77. Again, I can't do my 8 times table very well. I can't do 5 times 8, but I can do 8 times 5. So I'm going to do it that way instead. So 8 times 5, 5, 10, 15, 20, 25, 30, 35, 40. All that counting in 5s yesterday really helped me. 40. Okay. 18 add something is 29. So I know that's not an add question because the bit is missing inside the question. So I know it's actually a takeaway question. So I could do 29, take away 18. And that's what I'm going to do on my 10s and 1s today. And then I'm going to show you another way you could do it. 29, take away 18. And I can do 9, take away 8. And I can do 2, take away 1. So the answer is 11. And then what I'm going to do is I'm just going to check that 18 add 11 is actually 29. So 18 add 10 would be 28, add 1 more would be 29. So I have got that wrong right. Now, I promised you for my extension today, I wasn't just going to do 62 add 0, add 0. So what I've decided to do is I've decided to go for pretty much in half. So I'm going to go 20, add 20. So 20 add 20 is 40. And then I want 50, 62. So I'm going to do 22 here. Okay. Well, then what I'm going to do is I'm going to make that one smaller and that one bigger. And I'm going to leave that one the same. This time I'm going to leave this one the same. I'm going to make this one bigger and this one smaller, which is cheeky really, because all I've done is change around those numbers. So what I'm going to do this time is I'm going to take 10 away from here, so that's just going to give me 9. I'm going to add that 10 to this number, and I'm going to leave that one the same. I'm only going to change 2 numbers at a time, because otherwise I just think I'm going to get a bit confused, and I don't want to do that. I could have done that one differently. I could have done taking away the 10 from here and then putting 5 on this one and 5 on that one. But just trying to work out 3 numbers and remembering what I've got to do just gets a bit complicated for me. So I just like 2 numbers changed, and I'll leave one the same. And then this time I could change the different numbers, so I could have 9. And what I could do is I could take, I could add 10 to that one. So I'm going to add 10 to that and take 10 away from that one. So adding 10, taking away 10, leaving that one the same. And you just can keep going. So what I could do is I could add, let's add 1 to this one, and do nothing to that one, but take away the 1 from this one. So 10 add 42. It's all still 62. I'm just playing. I'm just moving numbers from one of these piles to the other pile. And today I didn't do it in any random order, which is making me feel a bit shaky, because I like doing it in random orders. In random order, I like the method. Moving on to today's lesson, we're going to be counting in 10. So let's just have a quick practice from 0 to 100. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We could actually go to 120, 110, 120. That would be 12 lots. When I was a little girl at school, a very, very, very long time ago, we used to stand up and recite a times table. We had them all written out across the top of our classroom. And every morning, my teacher would pick one of them, and we'd stand up to say we were doing the 10 times table and go, 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30. And we'd do that. And then we'd all sit down again. And every morning he would just pick one of the times tables. And I don't remember learning them off by heart, but I think eventually we must have done. Let's have a look at the 10 times table if we're counting in 10. So we have got 10, 20, 30, 40, 50, 60, 70, 80, 90, whoops, straight through the 90, and 100. So you notice they're all at the end of the 10s. What else do you notice about those numbers? I hope you notice that they've all got 0 at the end of them. Because all numbers, when you're counting in 10s, not adding on 10, because that isn't the same, but when you're counting in 10s, all the numbers end in 0. So let's have a look at our steps. So if you want to pause the video and do this before I do, then go ahead. Well, let's fill in the missing numbers. 0, 10, 20, and we've got 30, 40, 50, 60, 70, 80, 90. It's always good to have one in the middle to make sure that I'm doing it right. And next one is slightly more complicated. Again, if you want to pause and fill them in for yourself, go ahead and do so. 70, so let's go back. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. When I was younger and we used to have to write out our 10 times table as much as we could, I used to get to this bit here and I would just write 10, 20, 30, 40, 50 and then stick a 1 in front of it and then keep going and stick the 2 in front for the 200s. Always liked finding methods to help it make it easier. Okay, so we've got bar models, and you can see that each part of this is the same. So we have got 1, 2, 3 lots of 10 to make 30. So we've got 3 times 10. We've got 1, 2, 3 lots of 10, 20, 30. And because multiplication is commutative, we can change the numbers in the first part round. The answer has still got to be the same. And I'm saying this a lot because we're going to look at dividing after we've done multiplication and the answer changes. So with multiplication, the answer is always the same when you change the numbers in the question round. So it's your answer that stays the same and your numbers change places. This time we have got 1, 2, 3, 4, 5 lots of 10. And the really great thing is we don't even have to work out the answer because we've already been given it. We've got 5 lots of 10, 10, 20, 30, 40, 50. And again, the answer stays the same. And all we're doing is changing the numbers in the question around. So 10 times 5. And we know that from yesterday. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. It's the same. Okay, now we have 9 lots of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lots of 10. And again, we have been given the answer, but we could work that one out for ourselves. 10, 20, 30, 40, 50, 60, 70, 80, 90. The answer is going to stay the same, and the numbers are just going to swap places. So 10 times 9. If you could do your 9 times table, counting nines, you would find out that 10 times 9 was 90. I'm not going to prove that to you. Please trust me on this one. If you can count in nines, you can work it out for yourself. If not, just trust me. Right, let's have a look at Dexter. Dexter's got some money. So the first question says, and we need to be really careful and make sure we read the questions carefully. How many coins does he have? So it doesn't ask how much money he has. It asks how many coins he has. So he has 1, 2, 3, 4, 5, 6, 7. He has 7 coins. How much is 1 coin worth? So what are these coins? They are 10p. So 1 coin is 10p. So how much money does he have in total? Well, he has 7 coins and they are 10p each. We can ignore the p. I'm going to put it in my answer so I don't forget it. And we're going to do 7 times 10. So I'll do it on the coins on the, there, it's easier. 10, 20, 30, 40, 50, 60, 70. So he has 70p. Now, we need to make sure that the answer stays the same. So I'm going to squash my 70p in there. And we are swapping the numbers round. The p is stuck to the 10. The p doesn't change. It doesn't go to the 7. This p stays with the 10. So we've still got 10p and we've got 7 lots of them. So we've got 70p. So whatever coin it is, wherever the money is, it stays stuck to that number. It moves with the number. Right. So what I'd like you to do quickly, slowly, up to you, pause the video and see if you can answer these 3 questions, and then I will go through them with you. Okay. So we have some packs of crayons. There are 10 crayons in each pack. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many packs are there? So there are 1, 2, 3, 4, 5, 6 packs. And how many crayons in one pack? 10. It says so. 10. So how many crayons are there altogether? There are 6 packs of 10 crayons. So altogether there are 10, 20, 30, 40, 50, 60 crayons. And again, I can change that question round. 10 times 6 equals 60. See the answer. Okay, so we've got to move these cards. We've got to order them from the smallest to the greatest. And I wish I could do that like that. What I'm going to do is I'm just going to write the answers underneath so I can check. So if you want to pause the video and do that, go right ahead. 7 times 10. 10, 20, 30, 40, 50, 60, 70. That one's 70. I'm just going to put that there so I remember. 5 lots of 10, 10, 20, 30, 40, 50. 9 lots of 10, 10, 20, 30, 40, 50, 60, 70, 80, 90. And 3 lots of 10. It's much easier when it's in one hand. 10, 20, 30. Right. And it asked me to order them from the smallest. So the smallest one's got to go first. So which of these is smallest? 70, 50, 90 or 30? It is 30. So I'm going to move that. Whoops. Into that space there. Okay. And then what's next? I've got 70, 50, 90. The smallest one of those 3 is 50. Now I've got 70 and 90 left, so my smallest one is 70. I can move that one there. And then I can move my 90 there. Be really careful if you see a question like this, that you check which way you're ordering it from. It would be really sad to have done all that work and put them in the wrong order because you put the greatest one first. Just be really careful. Make sure you read the question carefully. Right, your turn. Challenge 1. How many cookies are there all together? So you've got cookie jars. Each cookie jar's got 10 cookies in it, and you have got 1, 2, 3, 4, 5, 6. I lost a count there. 1, 2, 3, 4, 5, 6. So you've got 6 lots of cookies. We have got 10, 20, 30, 40, 50, 60. So you could do your multiplication. 6 times 10 equals 60. And you can do it the other way around as well, if you're feeling very mathematical today. The next one is just like those ones we were doing earlier. You have got 4 lots of 10, so 4 times 10 is 40. Can you do the multiplication to match the bar model? And again, you can do the commutative multiplication too. Challenge 2, you've got a bar model. So can you do the multiplication sentences that go with that, just like we did earlier on in the lesson? And then you've got some cards. Now, each card has got a letter next to it. So you've got A, B, C, D, E, F, G, and H. And all you have to do is write down the letters of the cards, so there's more than one. I'm not telling you how many there are, but there's more than one that show 40. Okay, and that might be 40p with the coins. But which cards show 40? Okay, I'm not going to tell you how many there are, but there is more than one. Challenge 3, you've got your greater and less than signs and your equal signs. So again, work out what's on that side, work out what's on that side, and then decide which way round your crocodile is going, or if you need an equal sign. You don't need me to show you how to do this. You know how to do these. And then we've got our you've got challenge. I thought that was the extension, but we've got another challenge. We had one of these last week when we were doing our 2 times tables. These are good fun. So there are some of these base 10 sticks hidden behind this yellow block, and they aren't because it doesn't move, so I can't show you. The total is less than 100. So what could it be? So we've already got 10, 20, 30, 40, 50. We've already got 5 lots. So what else could you have? So I will give you an example. You could have one more 10 block there, and then you would have 6 times 10, which would be 60. You can think if there are some others. Tim says it could be 10 times 10. And is he correct? And explain. So it's no good just saying, yes, he's correct, or no, he's not correct. You have to explain to me why. And I'll tell you he's not correct. So explain to me why he's not correct. This isn't the only answer. There are others. See if you can find them all, or at least one more. And then the extension. That's what I thought we had before. So marbles come in packs of 10. Miley needs 56 marbles to complete her collection. And Miley says, I need to buy 6 bags of marbles. So is she correct? And explain why. So what you need to work out is how many marbles Miley needs, how many she'd get if she bought 6 bags, and does she need to buy 6 bags? Does she need to buy 7 bags? Does she need to buy 5 bags? So you can then write your sentence, the STEM sentence. I think Miley is correct. She does need 6 bags because, or I think Miley is incorrect. She doesn't need 6 bags because, and the because is the important part of this. So this is called reasoning. It's where you have to say why something happens or it doesn't happen. It's not good enough to just say yes or no. Why? Why is the important part? And I look forward to seeing all your work on Tapestry as always, and I will see you for the next maths lesson.